So knowing that we're dealing with sinusoidal functions again, remember, look for the pattern. Now, I've got the entire table of values written out here, but just like P4, think about it. All we really need is those quadrantial points. That point here, which is 1, 0, this point out here, which is 0, 1, this one, which is -1, 0, and this one, of course, which is 0, -1. And the most important thing also to remember is our CAST rule, add sugar to coffee rule. Yes, that's right. Okay, so let's deal with the ones that are really, really important. There's 0, there's pi over 2, there's pi, there's 3 pi over 2, and of course 4 pi over 2, which is just plain old 2 pi again. But now we're dealing with cosine. So remember that these are the x coordinates. That's what's important here. Okay, so let's put down the x coordinates, starting with, look at that. Sine started with 0, but cosine is actually starting with 1. Isn't that interesting? Now, that means our pi over 2, which is this guy right here, is now back to 0. Our next one, which would be pi, which would be now -1. Oh, that makes sense because cosine's only positive in quadrant 1 and quadrant 4. So we're already going into the negatives. Interesting. 3 pi over 2, which is over here, is back to 0, and then 2 pi is back to 1. That usually is enough to draw a nice sinusoidal function. You don't need much more than that because that, of course, is dealing with an entire period from 0 to 2 pi. You don't have to do much more than that. You know all the other points are going to be in between there. So I'm going to say let's just deal with those points and those points only. Here we go. So one of the cool things is that cosine actually starts at 1. Right? So if you want to really quickly just write down those coordinates, that nice little coordinate, there it is, starts at 1, goes to 0, to -1, goes back to 0, and back to 1 then, you can do this really, really quickly. Watch this. At pi over 2, so right in the middle between 0 and pi. So count it. 1, 2, 3, 4, 5, 6. Right in the middle will be 1, 2, 3. Down here, that of course is back down to 0. Then over here at pi is our -1, 0. Look at that, our -1, which is down here. Back to the middle here, which we're back to, of course, 0, -1. Look at that. Back to 0, -1 would be halfway in the middle between, look at that. Halfway in the middle again, between pi and 2 pi would be 1, 2, 3, which would be right back here, and then finally back over to 2 pi, which is right here at 1, 0. Oh my goodness. So look at our nice little graph. Check out how this works. Look at all the beautiful points I put down. Make sure it's a nice little curvy graph. Nice little curve on it. There it is. There it is. And that's what it looks like. That's why I refer to cosine as a cup-looking function. Now, we can do the same thing. Look, 1, 2, 3. Just go back. 1, 2, 3. It's going to hit here. 4, 5, 6 is going to be at -1. 4, 5, 6 is going to be at -1. Okay? And then, again, 1, 2, 3 from there, okay. 1, 2, 3 from there is 0, and then all the way out to 2 pi, whether it's 2 pi or -2 pi, it's going to be back up to 1. So you're going to get this beautiful looking graph going all the way along here and going up. Look how fast you can graph this just based on the quadrantial points because now you know the pattern. Oh my goodness, so much easier than plotting all the other points, huh?